Hey, welcome back. We're talking about substituting or solving systems by substituting. I'm Mr. Hayes, and we are going to formalize this and show you some more algebra type examples than just what we did in the experience video. If you want to see that, the link is down below in the description. While you're down there, like, subscribe, all that other good stuff. I was watching back the previous video. I think doing this part will work better this way, so pause where you need to, and we'll go from there. All right? So, big ideas in terms of solving by substitution is this. Okay. The thing to remember is that the variables have the same value within the system. So an x in 1, actually I'll just go ahead and delete that. Okay. This x here and this x here have the same value. Okay. So those have the same value. Now, once you get to a different problem, then they change. But within this one, it is the same value, and you can trade them. Okay, so if I can find something of equal value, you can trade that. Much like when you go to the store, the bill is $10, you trade something for that for the goods. It could be a $10 bill, it could be a $5 or 5 singles and a 5, it could be 10 singles, whatever setup that you need to do that. Okay. Likewise, these two y's are going to be the same value. Okay, and so that's where we get into that trading thing, because what we'll end up doing is we're going to trade one for the other. So if we find an equal value, we'll swap it out. Now remember, what we did earlier in the year is that we took one equation with one variable and solved it. That hopefully by this point is fairly easy for you. Now, when we have two equations and two unknowns, if we can make one of the equations into just a single variable equation by trading something out, all of a sudden, we go back to what happened first semester, and we're good to go. All right? So now over here, here's kind of more of a concept idea. We can trade a variable for something of equal value. That's always going to be the case. When I was growing up, we trade baseball cards. Oftentimes, we kind of get a sense of what the values were, or if you really wanted it. Okay? So as long as you have something that's equal, we'll trade it, and it's not a problem. How does that work with equations? Glad you asked. Okay. So, find the solution of each system. So notice right here, pardon me, I want to make sure I don't miss my notes. So how does that work inside of an algebra equation? This is how. Now, initially, this is where we're going to go. So notice right here, y has the same value as 13 plus 5x. If you have a y, I can give you 13 plus 5x. It's going to be the same value. Okay? Same way 100 pennies is the same as $1. Same value. So what we're going to do then is this. So here's you always play with the other equation. Other equations on top. So here's negative 3x plus 3y is equal to 3. Now remember, same values within the same equation. So what is this y? What is this y right here really worth? It's y, but it is also 15 or 13 plus 5x, right? So we can trade that. So we are going to trade this for 13 plus 5x. So when I rewrite this, I've got negative 3x plus 3 times 3 plus 5x is equal to 3. Ta-da! Now I have a single equation, only x in the equation, and hopefully, and I'm not saying you're super comfortable with it, hopefully you're like, wait a second, we did that first semester. I'm going to multiply the 3 out. So I get negative 3x plus 39 plus 15x is equal to 3. Combine up your like terms, just like you normally would. Oops, happen to be the same color. So that's going to become 12x plus 39 is equal to 3. I'm going to move this to the other side. and then divide it out. Now, once I get x equals -3, what we're going to do is we're going to plug that back into one of the equations. We're going to do another trade. So remember that y is equal to 13 plus 5x. I'm going to trade this x for a -3. So then when I do that, I'm going to get -2. So I'm going to write my final answer as this. Okay, I'll leave the other question for you to do. We'll talk more about it. Sometimes you're going to have to isolate this, just so you know. So I can get this by itself. So notice if I added y to both sides, I now have something that is substitutable. Okay, we're going to do some more practice on that. If you have any questions, let me know. Talk to you soon.